This lesson is how to multiply with fractions. Okay, let's say that you are making pumpkin muffins, and each recipe for pumpkin muffins takes 2/3 of a cup of sugar. Two-thirds a cup of sugar per recipe. Well, let's say that you're not just making muffins for yourself, but that you're also making muffins to take to 2 of your friends' houses. So you need to make 3 recipes worth of muffins. How many cups of sugar would you need for those 3 recipes? Well, there are a couple of ways to solve this problem. The inefficient way would be to do 2/3 plus 2/3 plus 2/3. But really, this is a multiplication problem. 2/3 times 3. Let's draw it out to see what that would look like so we can get a picture in our heads. All right, remember it's the magic whiteboard and it's just a model. So good thing, doesn't have to be perfect. Okay, so let's say that we've got our measuring cups here. And each measuring cup is 2/3 full of sugar. We're going to do brown sugar because it shows up better. There's 1/3, 2/3, stop. 1/3, 2/3, stop. So this is for the recipe 1, this is for recipe 2, and recipe 3 also has 2/3. So we have 3 groups of 2/3. Here's one group of 2/3, here's another group of 2/3, and here's another group of 2/3. And this phrase here, groups of, really means multiply. So really what we're doing is saying 3 times 2/3. Okay, now if we did this with a picture, what we would want to do is we would want to see, first of all, how many whole cups could be filled. So I just want to work with the last one here. This third, what if we poured it into this cup to fill it up? That would work. And now we don't have that third anymore. And we still have another third that we need to dump out. What if we poured it into that cup? Hey, got full. And I have nothing left in that cup. So 3 groups of 2/3 equals 2. 2 whole cups of sugar would be needed. Now wait, you might be thinking, I thought that whenever you multiplied, you always got a number bigger than what you started with. I started with 3, and I ended up with 2? That doesn't seem right. That doesn't make sense. Well, what you need to remember here is that your groups are not one whole. Your group size is only 2/3 of a whole cup. So if you had 3 groups of 1, then you would get 3. But we don't even have groups of 1. We have less than 1. So if we have 3 groups that are less than 1, we won't even have 3. So sometimes when you multiply, your answer actually gets smaller or lesser than what you started with. It all has to do with the size of your groups. Now, of course, we can't go around drawing pictures whenever we need to solve a math problem. Of course, we always can, but with bigger numbers, it might just really take a long time and be really obnoxious for you. So there's a shortcut. First of all, 3 whole is kind of like 3 firsts, 3/1. 3 divided by 1 is 3. So we can write 3 as a fraction with 1 as a denominator. Whenever you have a whole number, you can write it as a fraction with 1 as a denominator. Like 6 would be 6 firsts. Or 19 would be 19 divided by 1. Or like 203 would be 203 over 1. So, if we are truly dividing by 1, it's the same thing. It's going to set us up for success over here, though. Okay, so now we have 3 over 1 times 2 over 3. So 3 divided by 1 times 2 divided by 3, or 3/1 times 2/3. Well, let's see what happens here. When we multiply the numerators straight across. So 3 times 2 equals 6. And for our denominator, we get to do the same thing. Multiply the denominators straight across. 1 times 3, 3. So our fraction here is 6/3. And if we needed to simplify that, 6 divided by 3, lo and behold, equals 2. That's the answer that we got when we drew the model of filling up the cups of sugar. 2 whole cups. So the model is one way to draw it, and this is the shortcut for drawing it as well, or for solving it as well. Here's one more example. Okay, let's say Sarah made brownies for the bake sale at school. Late in the day, she had 1/4 of a pan full of brownies left. So let's split our pan up into 4ths. That means that this 4th got eaten, that 4th got eaten, that 4th got eaten, and she still has all of this left. 1/4 left. Now, what if Sarah's friend Margaret asked if she could buy 1/3 of what was left in the pan? What part of a pan, the whole pan of brownies, did Margaret buy? Whew. So Margaret wants to buy 1/3 of 1/4 of a pan of brownies. A 1/3 of 1/4. This word "of" right here, that means groups of, or multiplication. So she wants to buy 1/3 of the 1/4. So one thing that we could do is we could cut what's left into thirds. And Margaret is going to buy 1/3 of that 1/4. But now wait, our question asked us how much of the pan of brownies, this whole pan of brownies, did Margaret buy? In other words, we need to know what this amount is compared to the whole pan of brownies. We need to know what 1/3 of 1/4 is. So what if, even though these brownies are gone right here, what if we pretended like they were still here? They're ghost brownies. Because we still need to figure out what part of the pan was left. Okay, now we can figure out what the pan has been divided into. At first it was divided into 4ths. Now it's been divided into thirds. And we know how many of these little sections there are, so we can know how much of the whole pan Margaret bought. So let's count those sections to figure out what our fractional amount is. How many sections has this been divided into? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You might have also solved that by going 3 times 4 is 12. So now you have 12ths, and Margaret only bought one of those 12th size pieces. So Margaret bought 1/12 of the pan. Let's see if our shortcut works for this too. Our 1/3 times 1/4. We should end up with 1/12. Let's see if it works. Okay, 1 times 1 is 1, and 3 times 4 is 12. Hey, 1/12! It worked! Awesome! Again, it can be really weird for us to see such a small answer or a lesser value answer to a multiplication problem because we're used to things getting bigger when you multiply. But you have to remember that it is 1/3 of the 4th that you started with. You didn't even have a whole to start with. You only started with 1/4. And then you're only taking 1/3 of that, not even all of the 4th. So yeah, it's gonna get smaller. There's one more example that I want to show you with mixed numbers. All right, this one's ugly, not friendly at all. 3/5 times 1 3/8. Yikes! Well, the most efficient way to do this is not to draw it out, and it's not even to solve it as it is. This is going to be one of those times when it's really nice to actually have an improper fraction. This mixed number gets messy. So let's turn it into an improper fraction using our trick that we've learned already. So 8 times 1 is 8, and 8 plus 3 is 11. So 11/8. Okay, so now I can rewrite my problem as 3/5 times 11/8. Okay, let's see what happens when we follow our rules of multiplying fractions. So straight across the top, 3 times 11. And across the bottom, 5 times 8. 33/40. Check for common factors here. You might be able to simplify. Think about your factors of 33, because there are fewer factors of 33 than 40, so it might be nice to list those first and then we can check. So 1 and 33. Anything else? Let's see, is 2 a factor? No, it's not even. Is 3 a factor? Yeah, 3 times 11. Okay, what about 4? 4 times 8 is 32. Not quite. What about 5? No, it doesn't end with a 5 or a 0. What about 6? Well, 6 times 5 is 30. 6 times 6 is 36. 33 is right in the middle. 7? No. 8? No. 9? Nope. 10? Nope. 11? Yes, and we already have it. So the factors of 33 are 1, 3, 11, and 33. Are any of those also factors of 40? Just 1. And it wouldn't really do much good to divide the numerator and the denominator by 1. We'd still end up with 33/40. So when you see a mixed number like 1 3/8, for your shortcut to work really nicely, you can turn it into an improper fraction and then multiply those. All right, if you'd like to keep practicing on your own, solve these problems. Make sure that you're simplifying your answer in the end. Have fun.